Hello everyone, good day. Welcome to VSPARKZ. Today we are going to see some of the useful tips and tricks while working with Kubernetes. We are also going to see a demo on the same as well. If you like this video, please subscribe to VSPARKZ channel and click the bell icon for the latest updates. This is the agenda of this video. We are going to discuss on these topics in this video. Let us start with the first tip. Indentation and cursor column highlights for the YAML files. Most of the times for creating and modifying Kubernetes objects, we will be working with YAML definition files. While constructing these YAML definition files, we should be very careful to place the child fields under the parent fields. For example, let us consider this pod definition file. Here, if you see under spec, we have containers, DNS policy, restart policy as its sub-elements. Spec field is written at the start of a line while its sub-elements are written after leaving two spaces from the start of the line. This spacing is also called as indentation. It is not necessarily we should leave two spaces, but to have a nice look and feel, we are leaving two spaces. This will work even with a single space. If you do not leave spaces for child elements, Kubernetes will throw validation errors at the time of applying this definition file. Now you should know the importance of spacing in YAML definition files. To make us comfortable with the spacing and to highlight the columns, we have to set the tab stop and cursor column highlights in the Vim editor. Vim is one of the most popular Linux text editors. Once we set up these things in our CLI environment, the same pod definition file will be looking like this. Here we can see the cursor columns are highlighted in order to make us comfortable with the indentations. We can very well identify for any issues in the YAML definition files with respect to child and parent object indentation. Now we will see a demo on how to set up indentations and cursor column highlighting in the YAML definition files. Just to save the time, we have consolidated all the commands in a notepad and the same is available in the video description. This is our master node where we have connected to the cluster using the kubectl utility. This kubectl cluster info command shows the cluster status. Whereas this kubectl command will generate a minimal YAML template necessary to run a pod. Now we will redirect this output in a file. Now use the VI editor to view the contents of the file. Here you cannot see the cursor column getting highlighted. Now we will proceed to install Vim editor and we will configure the Vim editor to show the cursor columns while viewing the files. Vim is installed now. Before configuring Vim, do check for column highlights in the text files. Yeah, column is not highlighted. Now proceed for the Vim configuration. One thing to note here is tab stop, that is TS equals 2, which means when we press tab, our cursor will leave 2 spaces. So this spacing will be very useful when we define the parent and child fields in the YAML definition files. Now the configurations are all done for Vim. Now you can see the column is getting highlighted in the text files. Now it's tip number 2, bash autocompletion. If you see here, after typing kubectl command, the bash is not displaying or suggesting any of the possible subcommands for kubectl. With the help of shell or bash autocompletion, we don't need to memorize the kubectl commands to manipulate Kubernetes objects. In order to enable the autocompletion, we have to type source kubectl completion bash in the current shell. In order to make it work permanently even after reboots, we have to set up this command in the bash rc profile. Once you set up these settings in your current shell, just type kubectl and press a tab. We will be getting all the possible subcommands as the recommendation from bash. Until you get a complete kubectl command, you can press tabs to get the possible commands. Now we will see a demo on how to set up autocompletion in Linux bash environment. In most of the Linux system, this bash autocompletion package will be there by default. If not, try to install the same as it is needed for bash autocompletion. Here, when we type kubectl and then a tab, we cannot see the subcommands of kubectl, which means there is no bash autocompletion for kubectl. So in this machine, this bash autocompletion package is already installed. If it is not installed in your system, please do install the same. Now we will proceed with the bash autocompletion configuration. Now the configurations are done for autocompletion. Now try to press tabs after kubectl command. Here you can see all the subcommands for kubectl. Like this, we can press tabs until we get a complete kubectl command. Tip number 3, Alias for kubectl utility. While debugging or troubleshooting in Kubernetes, sometimes we may get annoyed when we have to type out kubectl command each and every time along with the other subcommands. Instead of typing out the entire kubectl command, we can create a simple alias for kubectl commands. This complete command is meant for bash autocompletion as well when we use k as the substitute for kubectl. In order to make this alias command work even after reboots, set up the same in the bash rc profile. After executing these commands, you can check the alias for kubectl using the type command. Now you can simply type k as a substitute for kubectl command. Now we will see a demo on how to set up Alias in Linux Bash environment. Now we will see how to set alias for kubectl and to configure auto-completion for that alias as well. Type K command shows there is no alias configured for letter K. Now we have configured alias for the letter K. We can see the configuration works perfectly. This complete command will enable auto-completion for the letter K as well. Now we can see the auto-completion is working for the letter K. Source this alias and complete command to the bash RC profile for persistence. Tip number 4, how to create Kubernetes YAML manifest files. Basically, there are two ways to create a YAML manifest. First is using some basic commands to create a simple YAML definition files. Second is writing on your own in the case of a complex YAML definition files. What I can suggest in the case of a complex definition is, first we can create a simple definition file, let it be pod, replica set, deployments, whatever it is. And on top of the simple definition, we can write all the complex specifications of that particular resource. Let us see how to create these things. First, we are going to create simple YAML templates using kubectl commands. Suppose say if we want to run just a single pod, use kubectl run command to generate the pod template. Let's see how. Using this command, we are creating the pod template and forwarding it to a text file. This will not trigger any resources at the back as it is a dry run. So in this template, just remove the unwanted lines and save it. Once it is saved, just apply this pod definition with a dry run command so that we can validate this entire definition. Yeah, our dry run is successful, which means the pod template is okay. Suppose if we want to create simple templates for other objects like deployments, replica sets, use kubectl create command to generate the template. Similar to pod template, we are creating the deployment template and forwarding it to a text file. Here you can see the template for the deployment. Now it's our second case. If we want to build complex resource templates, we have to know the exact skeleton or the definitions of the resources. To know what are all the resource definitions available in the Kubernetes cluster, we have to use kubectl API resources. Just for our comfort, we will execute these commands in another window. Seems the connection is lost to the Kubernetes cluster, and I think we should configure the kubeconfig file again when we open a new CLI session. Yeah, now we can see all the Kubernetes resources, its name, its kind, API version, etc. etc. Suppose say if you want to know the definition of a particular resource, just use kubectl explain command. Here we are explaining the pod resource. We can see all the definitions or the fields of a pod resource. In order to expand all these fields with its subfields and possible values, use the recursive operator. Let us try to use the recursive operator on the pod's spec subfield. With recursive operator, we can see all the fields expanded with the possible data type values as well. Now let us try to construct a pod.yaml file with the attribute of node name. As per the definition, the node name field should come under spec field, and that field should contain only string as its value. We already know how to construct this simple pod definition. Now try to modify this file with node name. So this node name field should come beneath spec field. We will keep worker node number 1 as its string value in the node name field. Some fields will accept maps, list of objects, and so on. For example, we will try to review the volumes and node selector subfields. Here we can see volumes are accepting list of objects. On the other hand, node selector is accepting a map which should have a key value pair. Both the key and the value should be in string format. So in this way, we can construct for all the complex parameters and fields in a resource definition file. That is with the help of kubectl explain command. Well, that's it for this lecture. This is the summary that we have discussed so far in this video. Thank you from VSPARKZ and thank you for watching this video.